Right, that's a little bit of notational work to start with. So if we just look at our complex plane that we've been playing around with, and I've got a random complex number, a, b, so this is a real axis and the imaginary axis as before, and if I have it in polar form, I have a length r and the angle theta. Then by some simple trig, this length along here is r cos theta, and the length up this side is r sine theta. So my complex number, a plus ib, is exactly the same as r cos theta plus I r sine theta, which I can put an r out the front, and I'm left with cos theta plus I sine theta. And a shorthand way of writing that is r cis theta. You'll sometimes see written. So it's exactly the same. R is the length and theta is the angle. So that's exactly the same as what I've been using that notation for previously. Because it's just a different way of writing it. So you can write it as R with the angle thing, theta, the length and the angle, or you can write it as R cis theta, which is alluding to the fact that it's actually a cos theta plus an I sine theta. So it's just carrying a little bit of information that talks about the cosine and the sine. It doesn't actually have it in there, but it says this is where it comes from. Okay, and this is what lies behind Euler's formula. So if we take Euler's formula, which I've given you up here, with an exponential, e to the power of, if I multiply both sides of this formula by r, re, I'm suddenly changing to j, but that shouldn't be a problem, equals r cos theta plus j sine theta. Expanding that bracket out gives us r cos theta plus j r sine theta. And r cos theta is exactly what I've determined as my real component of my number, plus j lots of r sine theta, which is the imaginary component. Okay, so r e to the j theta is the same as the complex number a plus jb. Okay, so I'm carrying exactly the same information as to where my complex number is in rectangular form, in polar form, and now in exponential form. Okay, so the exponential form is closely related to the polar form, and they've both got the same r, and they've both got the same theta. And when we write the complex number in this form, r e to the j theta, so e and j is fixed, but r and theta will change with each number. That's what we call exponential form.